Okay, so this lesson starts our algebraic expressions and equations module, excuse me. We are going to start working with algebra. Algebra deals with variables, and variables are letters or symbols that represent numbers. And we'll see that in some upcoming lessons. We'll also see it today a little bit as well. We're going to start out really basic and look at some relationship between operations that we'll then be using later on to help us more with some equations. So the first lesson, and this is a lesson that's going to combine two topics, and the first topic or lesson that we're looking at is the relationship of addition and subtraction. So you're probably going to feel like you're going back to like first grade in this lesson, but it's really a great intro to what we're going to be doing in algebra. So the first piece here asks us to draw a tape diagram to represent the following expression. And I'm going to stop right here and just explain that you will need to know the difference between an expression and an equation. An expression is a math problem written without an equal sign or an answer. So expression, no equal sign, no answer. So it's just the math problem. So in this case, the problem is 5 plus 4. So we're not really looking for an answer to this. We're just looking at the problem itself. So to draw a tape diagram of this, I would start by drawing a tape diagram of 5. And then adding on to it 4 more. And that shows me 5 plus 4. Pretty easy. So now it's just asking us to look at tape diagrams and write the expression. So in the first tape diagram, we have 1, 2, plus 1, 2. In the second one, we have 1, 2, 3, plus 1, 2, 3, 4. Pretty easy to start off with. Okay, so now we're going to work in the same type of manner, except we're going to just be drawing some tape diagram and doing some things to it to manipulate expressions. So we're going to start by drawing a tape diagram with 10 squares. I'm going to draw this under part A because that's where I'll be working with it next. So here's my tape with my 10 squares. And part A asks me to remove 6 of the squares by drawing an X through them. Now it's asking me to write an expression to represent the tape diagram. So just the math problem of what I just did. So I started with 10 and I took away 6. So 10 minus 6 is the expression that I did. Now what it wants me to do is add 6 squares onto the tape diagram. So I'm going to draw this tape diagram after I've already taken off those 6. So what was left is those 1, 2, 3, 4 that we see here. So I'll draw those 4, and then I'm going to add on 6 to that. So now what it wants me to do is alter the original expression, which is that 10 minus 6, to represent the current tape diagram. So after I started with that 10 and I took away 6, I added 6 more to it. So 10 minus 6 plus 6 is what they're looking for that expression. Now the next piece, they want me to evaluate the expression. And evaluate just means perform the operations. So do what it says in the problem. So the problem was 10 minus 6 plus 6. We did 10 minus 6 and we got 4. And then we took the 4 and added 6 more on. So we can count total to see what we got, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, in this problem, and what I'm going to do is I'm going to write this problem as a number sentence, which we'll see down here, which is also called an equation. An equation has a math problem, and it also includes an equal sign and an answer. So I'm going to write it up here, though. So I had 10 minus 6, I added 6, and I got 10. This is called an identity problem. It starts with a number. It does some math to it, and then you wind up back at that same number. So that's that identity piece. starting with something and ending up with it. If I look at this, I had taken away 6 and then added 6 back on. So I can actually read this problem backwards. This is 6 minus 6. So 6 minus 6 is 0. So if I have 10 and I subtract 0 from it, I end up back with 10 again. So that's kind of how it works. Or if I take 10 and I add 0 to it, I wind up back at 10. So now what they want me to do is write a number sentence or an equation, so with an equal sign and an answer. But instead of using the numbers 10 and 6, they want me to use the variables a and b, and that's going to represent those identities. And again, identity, starting with a number, doing some math to it, winding up back with that number again. We demonstrated with the tape diagrams. So I'm just going to take anywhere I see 10 in this equation and replace it with the letter A, and anywhere I see 6, I'm going to replace it with the letter B. So it's going to look like A minus B plus B is equal to A. So this is saying I can take a number, subtract something from it, add that same thing back on, and wind up back at that number again. This also works if I were to switch what I was doing. So if I were to take A and add B to it, and then take that B away, I would still end up back at A. B minus B is 0. Just as we set up here, we got 0 from doing the minus B plus B, so that was 0 as well. Okay, so let's look at some of the examples of this. So if I have 4 plus 5 minus something to get 4, that would mean I would need 5. 5 minus 5 gives me that 0. I need to add to the 4 to get 4. So if I have 25 minus something plus 10 equals 25, that would be minus 10. Minus 10 plus 10 would be that 0 I was looking for. I'm starting with something, adding 16 to it, subtracting 16 from that, and winding up at 45. That means I should have started with 45. 2 now brings in the variable aspect of this. So if I have A plus B minus something to get A, I must be subtracting B. If I have C minus D plus D, that would bring me back to C again. And if I have E plus something minus F to get E, it must be F that I'm adding on. So that's the end of that first lesson, showing the relationship between addition and subtraction. Just if we add something on and then subtract that same thing, we wind up back at the same number. Now we're going to look at the relationship between multiplication and division. So it says, using squares, make a pictorial representation of the division and multiplication problems. So 8 divided by 2, as we saw with when we were working in the dividing fractions, this can read as how many groups of 2 are in 8? Or it can read as 8 is 2 groups of what number? So this is just a little review here. Okay, so if we're doing how many groups of 2 are in 8, I can draw 8 and circle groups of 2. 1 group, 2 groups, 3 groups, 4 groups, to see that 8 divided by 2 is equal to 4. If I'm doing 8 is 2 groups of what number, I would start with 2 groups and dole out the 8. So 1 here, 1 here. So that's 2, 3, 4, 5, 6, 7, 8, and see that there's 4 in each group. Okay, so 2 different ways to look at that division problem. If I'm doing 3 times 2, I can do 2 groups of 3, which would be equal to 1, 2, 3, 4, 5, 6, or I can do 3 groups of 2, which again is going to give me the 2, 4, 6 that I'm looking for from 3 times 2. So just different ways to look at division and multiplication problems. Now we're going to do the same thing we did previously, and we're going to follow some steps. We're going to start with a tape diagram of 10 squares again. And the first thing asks me to divide the squares into 5 equal groups. So to do that, 5 equal groups, I would be circling groups of 2 to make 5 equal sized groups. To write an expression to represent the tape diagram, we started with 10 and split it up into 5 equal groups. Part B asks us to take the number in each individual group, so that's 1, 2 in each group, and multiply it by 5. So draw 5 of those. It then wants us to alter the original expression, which is that 10 divided by 5, to represent the current tape diagram. So now after we did the 10 divided by 5, split it up into 5 equal groups, we then multiplied it by 5. Now it wants us to evaluate the expression. Remember, evaluate is just perform the operations. So I had 10 divided by 5 and then multiply by 5. 10 divided by 5 was groups of 2. It then took the 2 times 5, 2, 4, 6, 8, 10, and gave us back 10 again. So this once again is another identity, this time just using division and multiplication. Start with 10, do a multiplication and division of the same number to wind back up at 10 again. Now they want us to write the number sentence using variables a and b to represent the identities we demonstrated with tape diagrams. So again, I'm just going to replace the 10s with a's and the 5s with b's. So a divided by 5 times 5, and actually I was about to write the x, but when we use variables, and I didn't use b, so a divided by b, times b gives us back a again. When we use variables, we try to use the dot when we're showing multiplication, just because if we don't, it looks like the letter x, and that can get very confusing because a variable can also be the letter x. Now, just as with the addition and subtraction, this works the opposite way too. So if I have a and I multiply it by b and then divide by b, I'll still wind up back at a again. And it's actually kind of seen nicely here. B divided by b, anything divided by itself would be 1. So a times 1 is back to a. Okay, so let's look at some examples. So if I start with 132, I divide it by 3 and then multiply by 3. I wind up back at 132. I start with something, divide it by 25, multiply by 25, and get 225. That means I must have started with 225. And if I did d divided by c times something to get d, it must be c I'm multiplying by. R divided by something times s is equal to r. I must be dividing by s.